Hi, and welcome back to another video in this series. After the last video of the social reconnaissance, social engineering reconnaissance, we're going to go back into a bit more technical, well, a lot more technical actually, just a bit. We're going to be going over encryption and hashing, right? So for our first exercise, this is something that I see as a challenge, but an exciting challenge at the same time, right? I love it. So what we're going to do first is getting through cryptographic basics. So the cryptography tools, they're used to generate and confirm the integrity of information, right? That can be used for confidentiality, to protect from the unauthorized viewing of materials, right? So it assists with securing information, right, that we're receiving from a source location. Further, with some hashing, we can confirm. For example, a program, we have downloaded that it hasn't been modified in some manner by checking its hash value produced by the author. With our own values. So we're just going to do a few things. We're going to do some crypto demo installation, crypto demo encryption, decryption, key values, some hashing, some fun stuff, right? So first, let's get started with the install. So we're going to install the tool and prepare it to use it for the cryptographic basics, right? So, all right, yeah, we're on the right server here, so we're good to go. Now I'm just going to open up Internet Explorer. Is this Internet Explorer? I thought this was. Okay, let's see, Internet. All right, so we're going to go to hacking tools. Yeah. So it's moving kind of slow here. Well, this is Edge. Get them mixed up. All right. All right, tools. Let's see. There it is. Okay. Should be a zipped program. Let's see. I think it's this one. Let me go back. It should be demo. There it is. Right. Actually, hold on. Actually, let me go back here. There it is. There it is. Let me go back. Okay, there it is. Okay, that was gonna do that for me. All right, so I'm extracting all. All right, so I might get an account control warning, but I doubt it. No, I didn't. Okay. Perfect. Yep. Okay, so should be a continue button here. There it is. All right, so continue. Okay, perfect. All right, so let's see. Should be open here. Actually, you know what? No, this won't work. There it is. All right, perfect. Finally, sorry about that. So now we can see the program in the start menu, and we've opened it up as far as the crypto demo 1.0. So now we're just going to get to some crypto demo encryption. So we're going to apply the encryption algorithm to 3DES to see the output and begin to recognize what such an output generates in terms of values, and it can help experience people recognize different algorithms just on site, right? So I'm going to take a moment just to study the interface because the program is designed to assisting in just learning more about encryption for the most part. So I'm just going to dig around here, see the SHA, MD, getting hash, random key. All right, perfect. All right, so just going to expand this the drop down menu, and then I'm going to, okay, actually we're already there. All right, perfect. All right, so now, let's see, practice labs. This is for the key. And let's enter some text here. Really, I know when it comes to uppercase and lowercase, but that. Okay. Perfect, perfect. All right, so now just going to click the encrypt button here so that I can see the result of the encryption and the result that will be displayed in the encrypted data field, which is right here. All right, so I can click it as many times as I like, and I'll see different results of data output. It's one of the most important concepts behind encrypting a text because the ciphertext should be different and unreadable, right? So now we're just going to do some CryptoDemo decryption, right? So to decrypt the content and make sure that it has the same content as originally intended. So we want to be careful. So just to delete only the data field, right, containing the text that I entered and to not change the key or the algorithm type. We're just gonna here, oh, excuse me, then decrypt. Oh, wow, it fully decrypted it. That's amazing. But I do have the same original text decrypted from the data, and I can actually try other algorithm encryptions, right? So I can change it to DES, and then encrypt, decrypt. I can do this here, decrypt, right? And it's gonna just make it look a bit different as far as how the hash, well, the encryption looks, right? So I'm gonna do it one more time. I just like seeing it change. I don't know why. So I'm gonna try deleting a single character from the encrypted data, and then see the last what happens here. See. Wow, unexpected. So wow, um, so it wasn't able to decode the encrypted data, which is good, right? So this allows us to move into our next exercise to address key values, right? So in general, mixing up as many possible variables with long string lengths and that produces a strong key to encrypt or hash against, right? However, we will use options usually presented with like random key and time key, right? So we can actually apply this key formats to see the results. So previously we input our own, right? So it was a poorly secure key, of course, and the better option would be to generate a random or time key, time value key, which is a lot more secure. So I'm just gonna delete this here. Let's see. Okay, there it is. All right, perfect. So now I'm gonna try random key to see what key I'm presented with. There it is. See the change here. All right. Actually, you know what? Let me do this. Oh, okay. Actually, let me have a little fun. let me let me have a little fun here. Oh, come on. I can't wait till that show comes back. All right, so I'm just gonna that there, and then encrypt, and we can see the time key shows the next time it'll change again, right? But then we do the random key, it's just going to give us a different key for the data that we have here that's going to be encrypted, right? Oh, excuse me. All right, um, so yeah, it'll give us a different result depending on the type of key that we're using, right? So so also use encrypted multiple times and use multiple texts to determine what the encrypted data would look like here in the encrypted data text box, right? So now this allows us to get into hashing in particular, right? So hashing a value, it's used to map data size, data of any size really, and provide a method for verifying the integrity and also the authentic, authenticity of the data now authored. Um, so we're going to see the hashing algorithm here for the MD5, which is a very common hashing type. So now I'm just going to write in here. Um, let's see. Let's see. Okay. So I've just written in our, that's another great classic anime. Uh, but unlike the encryption stage, right, this hash, it won't change if we click the button, right, get hash, right? So we can click it as many times as we want, it won't change, right? So now we can actually change the hashing algorithm, right? So I'll do this one, right? Now it changes. So we'll get a different result for each algorithm, right? So change it to there, change it to there, and that's the only way it'll change as far as the different algorithms, right? So now let's get into actually comparing the different hashing algorithms, right? So we can look at a different variety of algorithms in a direct comparison and using hash calculations, which is a calculator that provides a message digest, checksums, and HMAX for files as well as for text and hex strings. This provides just about 13 popular, really, hash and checksum algorithms for calculations. So we're just going to use the install of HashCalc and using HashCalc. All right, so first let's get to the install. So I'm going to go to the directory drive. See, let me go back here. Actually, I think I was already there. Let's see, which directory drive? Looking for it here. All right, so let's see. So this one here, I believe. There it is. All right, perfect. HashCalc. Of course, I accept. All right, and yeah, I'm just gonna use the default. And yeah, yeah, I'll just leave it at HashCalc. Yeah, sure. Wait, create one of those. Just get it over with. Let's see. All right, just going to make sure that the all the tick boxes are also confirmed for all the hashing algorithms except for HMAC, which should be left empty. Yeah. All right. Perfect. And calculate. Then we see all the different hash types and how they come up with their text string. Right. So we can change the data in the field to anything that we like here. Right. Just whatever, just so we can see how the different values of hashes compare to each other. And when we do that, let me go back here. Just let me be quick today. All right. All right. Just saw the live action for this on on Netflix, and it so far looks pretty good. Okay, so that's on the top of my head. What's the name of that other one? Go. I still have to finish this. Let's see. Okay, all right, not bad. So, as I mentioned, we can change it to anything we like, just so we can, essentially see the different algorithms that produce hashes of set lengths, which could be used to identify them, right? So now that we check the HMAC value, right, then we'll only see a specified number of hash types that will be permitted, unfortunately. Well, not unfortunately, that's just how it works. This is because the keyed hash message authentication code is a specific use of hash functions. But we can edit the key format to allow text strings or hex strings, but I can use text. So I can use, let's see. Let me copy that. I don't know why I'm anal about this. Perfect. So let's see this. All right, perfect. And of course, when we calculate to see our results, we got to remember that the hashes were made with a specific key that was entered in. Usually this would be a secret key. All right, so I can change it to a hex, then see what that looks like. Huh? Invalid symbol. Must be even. Does that have to be lowercase? Okay, let's see what's going on with this. All right, really quickly. So I just figured out why initially it wasn't populating with the initial keys that I had for the hex string for the HMAC format. So what I've learned is that the hexadecimal strings, right, for the key format, it contains characters that are not valid. It could potentially contain characters not valid in hexadecimal notations, right? So the string should only include characters 0 through 9 and A through F, or A through F for at least lowercase. So that's why now I'm able to calculate. But prior, when I was using just a simple word like this, it wouldn't calculate anything for me, right? So just a little tidbit from me that that came across, right? So now we're going to load a file to HashCalc to be evaluated. So in the data format change, we're going to change the field to file. Let's see, there we go. All right, perfect. And now we're going to install the 0.77 version of PuTTY. So just going to open up Internet Explorer. Actually, yeah, actually, I'll just leave that in mind. Anyway, so let's head to the site. Now we're going to here. Let's see. Where's Mountain? Okay. All right, so maybe missing something, but let's see if it still, it doesn't. All right, let's fix that. All right, so I've reached the PuTTY website in order to download it. So now let's go ahead and get to the PuTTY. Let's see, the 64-bit installer. Let's see if it's here. Let's see. Which one? Okay. That is right. Let's save. All right, perfect, perfect. All right, so now I'm just gonna, while I do that, I'm just gonna go back here. Let's see. Connect to. Not. All right, so now we're back on track. All right, so I got the HashCalc program now open again. So just gonna head to the documents, all right, and then installer here, and then open, all right. And then this will load the file into HashCalc to see what values are produced, right? So let's see, uncheck that one, then calculate. And let's see what happens. Oh, perfect, perfect. So now that we can compare the hashes for this file, right, to the hashes which are online for the putty.exe, right? So however we notice these values are long, right? It can be difficult to read. In the next exercise, I'm going to show how to compare the hash that we calculated with the downloaded file, the official hash produced to us by the creator of the file, right? So this will allow us to confirm what we have is the correct file and if it has not been modified in any way. So this is important to know, especially if we receive the file from an external site rather than the creator of the file directly, right? So now to compare the hash files, I'm just going to compare the different values to get a better understanding of how hashes visually compare to each other in that state. So we'll be doing some grabbing website hashes and using an online comparison tool. So let's see. So grabbing a website hash values. So each opt-in, actually, let me close this here. I'll just leave this open. All right, so each opt-in, a website, it has a hash value of the program that it's author, right? So these values are usually made by the author. We use them to actually confirm the integrity of the programs or files, to confirm that they're original and unaltered during transit, right? So using the hash values produced by the HashCalc, we will now compare them to the official values. And this is used to make sure that we have files to maintain, which maintain their integrity. So it helps to ensure that files have not been altered or anything, right? So in terms of programs, it's an essential component that malicious code has not been injected into the putty.exe. So let's see here. Let's see. Where's the checksums here? There it is. All right. I see it here. All right. So now, let's see. For two files, let's look at this one. Perfect. Perfect. All right. And so usually whenever you see it like this also, you can click the settings icon at the top right to change the zoom setting to view more than once. So for instance, we can just, I'm on a Mac, so the controls are a little, may not work as the same. But you can just, here, here, so you can get a better view of depending on how you like to look at hashes, right? So we see that the MD5 sum that we've just requested for the PuTTY installer ends in DD66. And this can be found usually by using Control and F and then entering the details of the installer, right? Because it's the string of letters of the numbers before W64, right? Which is the beginning of the PuTTY file, right? So let's see here. All right, so taking a look at this hash. Take a look back. Yeah, that's slightly better. I like it in between 50 and 75%, but that's fine. So, so perfect. So now we see that, and then we also see that the hash for this file, the SHA1 sum for the PuTTY installer ends in F151. Again, we can't really see it because of the zoom, but that's what it is. And again, it can't be used. Let's see if it actually works. Oh, it does. Okay. All right. So let's see here. Perfect. There it is. All right. So we found that, right? So now we're going to use the online comparison tool. And the original site, it kind of aids in comparing values against each other to check whether we have the same hash values as the original. So we're going to use this online tool to combine it with the HashCalc results. So I'm just going to open up another tab. All right. And then I'm going to do, and okay. Let's see, that doesn't work. So I'm going to use this link here. Come on. There it is. I put this in on that. See, that's a bit better. All right, perfect. So now we're going to compare the values for both the MD5 and the SHA1, the SHA1, found on a website with the values generated by the hash calculator. So make sure. All right, perfect. So we also want to make sure that when we're checking these, we have the correct hash value selected as well, checked off, right? So just going to copy the, let's see, I won't click on my actual browser. All right, so let's do this here. Right. And then that was the, which one was that? I think it was the SHA1. Right. All right. Mm-hmm. And oh, Need to open this one here. Right. Calculate. Okay, that's not good. All right, perfect. So I got everything back on track, and let's go ahead and compare. Now, where the green check mark is where the hash calc, where I got that data from, and then this is also from directly from the site, right? And I have the green check mark here, right? As far as the hash, now I'm just going to do just for giggles here. Just going to do MD5. All right, and then for this one, actually, no, this should be here. Yeah, that's what I want. Come on. Here. And then see. Perfect. All right. I love it. I love it. I love it. All right. So we did the same job as far as the comparisons with the SHA-1 by comparing the files from the hash calc to what we were able to generate as far as the hash online directly. So we have a positive result of a hash for both hash values, and we can also do a check. I'm not going to do that today, but we could have done a check for the SHA-256. So this is the end of the video now, and just for a very brief recap of what we've done in this video, we've went over the cryptographic basics for the most part, at least. We compared hashing algorithms, and we also compared hash values. So that's the end of the video for encryption and hashing, and I'll see you in the next one.